Welcome to EduRev.
Hi children, welcome to EduRev classes. I'm Sarvani Nandipati, your maths educator. I have done my graduation from NIT Calicut and I have more than 3 years of teaching experience. This is our real numbers part 3 video. The first 2 videos is about Euclid division lemma and fundamental theorem of arithmetic. If you are not clear with those topics, you can watch those videos as well. And in this video, I'll be covering the topic irrational number, specifically how to prove a given number is irrational number, and to prove that we'll be using a theorem and I'll be proving that theorem as well, and we'll solve few problems. Let's get started. First, look at the theorem. Let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. So they are telling P is a prime number, and if P divides A square, then we can come to a conclusion that P divides A, where A represents any positive integer. So now look at the proof. The prime factorization of the A is as follows. A is equal to P1 into P2 into and so on till Pn, where P1, P2, P3 and so on Pn are primes not necessarily distinct. So how they are writing it as A is equal to P1 into P2 into P3 and so on till Pn, and they are not distinct. That means they are not different. How they are writing that? Let's look at an example. I am taking A as 12. So what will be the prime factorization of 12? 2 into 2 into 3. So here, if I have to correlate with whatever is given, A is equal to P1 into P2 into P3. But 12 is equal to 2 into 2 into 3. So P1 is equal to 2 and P2 is equal to 2. Here both are also becoming same. So in the same way, if you take some other numbers also, it's not necessary that all the terms that you are multiplying should be different. They could be same also. So that is how they are representing for a general number. A is equal to P1 into P2 and so on till Pn, and it's not necessary that all of them are distinct. A square, they are doing squaring on both sides. So what will be that? P1, P2 and so on Pn whole square. So if it is A square, you can write it as A into A, right? Similarly, P1, P2 and so on till Pn whole square, how can you write? P1, P2 and so on Pn into P1, P2, P3 and so on till Pn. So now what are the common terms? P1 is multiplied 2 times. So P1 into P1 I can write as P1 square, and P2 into P2 I can write as P2 square. Similarly, Pn into Pn will be Pn square. But what was the information given? P divides A square. See, that was given here. If P divides A square, our condition is to prove that P divides A. So I am assuming that the given condition P divides A square. So based on the fundamental theorem of arithmetic, what do we know? P should be one of the factor of A square if P is dividing A square. So what are the prime factors of A square? P1, P2 and so on till Pn. Because A square is written as P1 square into P2 square into Pn square, all are prime numbers. So P should be one among P1, P2 and so on Pn, because P is the prime factor that divides A square, and prime factors of A square are nothing but P1, P2 and so on till Pn. So with these two conclusions, I am coming to a conclusion. With these two statements, I am coming to a conclusion that P is one of the P1, P2 and so on Pn. If P belongs to any one of these elements, P1, P2 and so on Pn, then it will divide A. Why? Because A is nothing but the product of P1, P2 and so on Pn, right? If P belongs to any one of those elements, obviously it should divide A. So we can come to the conclusion that P divides A. We have taken the information P divides A square, and we are able to come to the conclusion that P divides A. Given P is a prime number and A is a positive integer. I hope it is clear. I am moving on to the next question. Prove root 7 is irrational. To do this, I will be using the theorem just now we have studied, and I will be using an approach called method of contradiction. What is that? If I am supposed to prove a statement, I will take an assumption which is actually opposite of that statement, and then I will proceed further. As I proceed further, the conclusion that I am going to get is completely contrary to the assumption that I have taken. Why is that happening? Because my assumption is wrong. So you are going to tell that the statement is right. So this approach is called method of contradiction. So I will be using that to prove root 7 is irrational or any other problems to prove it as irrational. So if I have to prove root 7 is irrational, my statement should be root 7 is rational. So that is what I am assuming. If a number is rational, I can write it in the form of p by q, right? So I am representing root 7 as a by b, where ab belongs to z and b should not be equals to 0. And I am taking another assumption that a and b are co-primes. Co-primes means they should not have common factor other than 1. They should have the common factor as only 1. No other factor should be there. So I brought b to the other side. Here it is dividing. If it goes to the other side, it will multiply. So b root 7 is equal to a. If I apply squaring on both sides, what will happen? b square into 7 is equal to a square. So that means what? A square is equal to 7 into b square. So if you can write as a square is equal to 7 into something, that means 7 is a factor of a. 7 is a factor of a square. That means 7 divides a square. Right? If 7 divides a square, based on our theorem, 7 should also divide a. Right? So I'm considering a is divisible by 7. In that case, how can I represent a? A is equal to 7 into some number. I don't know what is that number, but I can write as a is equal to 7 into c, where say belongs to some integer. Now, I am going to substitute a is equal to 7c in our equation 1. What is our equation 1? 7b square is equal to a square. So 7b square will be 7c whole square. What will be 7c whole square? 7 square c square, that is 49c square. So our statement is going to become 7b square is equal to 49c square. So 7 gets cancelled, right? 49 gets cancelled, right? 7 tables 7 times. So these gets cancelled. So the value is b square is equal to 7c square. So if b square is equal to 7c square, that means what? B square is equal to 7 into something. So I can write 7 is the factor of b square, right? Or 7 divides b square. If 7 divides b square, based on our theorem, I can write 7 divides b, or b is divisible by 7. So what is happening? From the first statement, I understood that, see here, a is divisible by 7. And here I am getting b is divisible by 7. So what can I come to a conclusion? 7 is a factor for both a and also b. But what was the initial assumption that I have taken? A, B are co-primes. That means they should not have any factor other than 1. But what am I getting? 7 is a factor of both A and B. So our assumption itself became wrong, even though our procedure is not wrong. All the steps that we have done in the procedure is right. But whatever we are getting, the conclusion that we are getting is completely contrary to our assumption. This is happening only because the statement that we have assumed root 7 is rational is wrong. So now I can conclude that root 7 is rational. Because the assumption we have made A and B are co-primes is contradicting, and this is only happening because our assumption was wrong. We haven't gone wrong in any one of these steps that we have written here. So I hope it is clear. So whenever they give you, it's not necessary that root 7 only, they can give you root 2, root 5, root 3. All of them, the procedure will be same. You simply have to change the number and do. Assuming it is clear, I am moving on to the next slide. Prove 2 plus 3 root 7 is irrational. I am assuming 2 plus 3 root 7 is rational. So if it is a rational number, it can be represented in the form of a by b, where ab belongs to z and b not equals to 0. And again I am making an assumption that a and b are co-primes. That means the only common factor is 1. Now how can I write 3 root 7? A by b minus 2. This plus 2 I am taking it to the other side, so it's becoming a by b minus 2. And what is root 7? If this 3, here it is multiplying, if it comes to the other side, it will divide. So it's 1 by 3 into a by b minus 2. And in our earlier classes, we have already studied, if we add two rational numbers, or if we subtract two rational numbers, if we multiply two rational numbers, or if we divide two rational numbers, the output that you are going to get will always be a rational number. So look at this part. A by B is a rational number, 2 is a rational number, simply 2 by 1 you can write. So here these are nothing but subtraction of two rational numbers, so this should be a rational number. And 1 by 3 is a rational number, and the output that you are going to get for A by B minus 2 is also a rational number. If you are multiplying two rational numbers, then also the outcome should be again a rational number. So I can conclude that this part is rational. But what is the other part? Root 7. Is that a rational number? No, it is a irrational number. Right? Just now we were able to prove root 7 is irrational. So can any time will a rational number be equal to an irrational number? No. Why is this happening? Only because the assumption that we have taken was wrong, that 2 plus 3 root 7 is rational. So what can I come to the conclusion? 2 plus 3 root 7 is irrational. It's not rational. So just remember, whatever is given, write it as in the form of A by B. Assume AB belongs to integers and B is not equal to 0 and AB should be co-primes. After that, write it in its simplest form. Here I have written root 7 is equal to 1 by 3 into A by B minus 2. The RHS part is a rational number where the LHS part is an irrational number. A rational number will never be equal to an irrational number. So the conclusion that we are going to get is wrong irrespective of the procedure was right. So why did we come to a wrong conclusion? Because our assumption is wrong. So if my assumption is wrong, what should be the correct statement? 2 plus 3 root 7 is irrational. So I hope it is clear. That is what I have mentioned here. I am moving on to the next slide. Show that there is no integer for which root of n plus 1 plus root of n minus 1 is rational. So what they are asking us to prove, when whatever value you take for n, as long as n belongs to integers, root n plus 1 plus root n minus 1 is not rational. That is what we are supposed to prove. We will be again using method of contradiction. So what will be our statement? Root of n plus 1 plus root of n minus 1 is rational. And we will proceed further. What do we get at the end? The assumptions that we have taken were wrong. So with the method of contradiction, I can prove that the given assumption is wrong. So root n plus 1 plus root of n minus 1 is irrational. So let's get started. I am assuming that root of n plus 1 plus root of n minus 1 is rational. So I can write it in the form of p by q. Now what am I doing is I am reversing them. So p by q, if it comes to the other side, it will be q by p, and this term will be simply 1 by root of n plus 1 plus root of n minus 1. See, I am simply reversing that. If it is a by b is equal to c by d, I can write it as b by a is equal to d by c. The same logic I have applied here. And the denominator is having a surd, right? It's in the roots form. So to make it rationalize, what should I do? I have to multiply it with root of n plus 1 minus root of n minus 1. So I am doing that. Always remember, in the denominator, if it is root a plus root b, you have to multiply it with root a minus root b to make it rationalized. I have root n plus 1 plus root n minus 1. So I am multiplying it with root n plus 1 minus root n minus 1 by root n plus 1 minus root n minus 1. So if you look at this clearly, how they look like? It's like a and this is your b, right? And this is also a and this is also b. So it's in the form of a plus b into a minus b. What is the formula? A square minus b square. So here root n plus 1 into root n plus 1 will be root n plus 1 whole square minus root n minus 1 into root n minus 1. So the value will be simply root n plus 1 whole square minus root n minus 1 whole square. It's n plus 1 minus of n minus 1 because the root and the square gets cancelled. And what will happen? Minus, if I open the brackets, it will be minus n and plus 1. So plus n and minus n gets cancelled. So the denominator will have simply 2. And that 2, if we bring it to the other side, it will be 2q by p. So here the value that is going to left will be simply 2, right? So that 2, if I bring it to the other side, it will be 2q by p. And in the numerator, root of n plus 1 minus root n minus 1. Look at these two statements, 1 and 2. I am going to add both of them. What will happen? Root n plus 1 plus root n minus 1 plus root n plus 1 minus root n minus 1. That should be equal to RHS part, that is p by q plus 2q by p. Here which terms gets cancelled? The root n minus 1 term gets cancelled. So what you are going to get? 2 times root of n plus 1 is equal to, if I take LCM, p square plus 2q square by pq. So what will be root n plus 1? P square plus 2q square by 2pq, because this 2 I have brought it to the other side. And this part is completely a rational number. The RHS part, p square plus 2q square by 2pq, is a rational number. That means the LHS part should also be a rational number. So I can come to a conclusion that root of n plus 1 is rational with our assumption. Now I am taking that statement as my third statement. Similarly, what I am going to do is I am subtracting the second equation from the first equation. What will happen? Root n plus 1 plus root n minus 1 minus of root n plus 1 minus root n minus 1 is equal to p by q minus 2q by p. And here which terms gets cancelled? See, if I multiply with minus sign, this will become minus root n plus 1, and minus of minus, this term will become plus root of n minus 1. So the root n plus 1 terms gets cancelled in this case, and root n minus 1 plus root n minus 1 will be simply 2 root n minus 1, and if I take LCM here, it's p square minus 2q square by pq. And here 2 is multiplying, if it comes to the other side, it will divide. So root n minus 1 is equal to p square minus 2q square by 2pq. And in this statement, what is my RHS part? It is simply a rational number. But so what can I come to a conclusion? My LHS part is also a rational number. That means root of n minus 1 should also be a rational number. I hope you are clear till this part. What we were able to prove is root of n plus 1 is rational and root of n minus 1 is rational. If you add two rational numbers, the value that you are going to get should also be a rational number, right? So that is what I am going to do. Based on the third and fourth statements, I am coming to the conclusion that root n plus 1 plus root n minus 1 must be rational. Why? Because I got this term as a rational term and this term also a rational term. So this sum should also be a rational term. If these terms are supposed to be rationals, what should be the condition? This value under the root should be a perfect square. Then only the root and the square gets cancelled and you will get a normal number or the rational number. So I can come to a conclusion that n plus 1 and n minus 1 must be perfect squares, right? Simply find the difference between them. What will be the difference between them? N plus 1 minus of n minus 1. What is that? N gets cancelled. 1 minus of minus 1 is 1 plus 1, 2. So you are able to prove that root of n plus 1 plus root of n minus 1 is a rational number, but there should be a condition that the difference between those two perfect squares should be only 2. Now we'll just look at perfect squares. What are perfect squares? 1, 4, 9, 16, 25, 36, 49 and so on. What is the difference between those numbers? Check between 1 and 4. The value was simply 3. And here for 4 and 9 the value was 5. And then for 9 and 16 the value was 7. For 16 and 25 the value was 9. So the minimum difference that you are going to get was 3, because if I go to the other perfect square numbers, the value was increasing, right? with the basic definition of the perfect squares, the difference between any two perfect squares should be equal to 3 at minimum. The minimum value, the maximum could be anything. But what we have got is the difference between two perfect squares is 2, which is completely a wrong statement. But in the procedure when we are performing, we haven't gone anywhere wrong. The only wrong thing, if it had happened, it's only because of our assumption. So our assumption that root n plus 1 plus root n minus 1 is rational is wrong. That indicates, what can I conclude? Root n plus 1 plus root n minus 1 is not rational for all integers, or no integer will satisfy the condition root n plus 1 plus root n minus 1 is rational. So this is how we will be solving the problems when you get. I hope it is clear. I am moving on to the next slide. So I will be ending today's video session here. What did we learn? We learned the theorem. If p divides a square, p divides a, where p is a prime number and a is a integer. A is a positive integer. And after that, we have learned the concept of method of contradiction and how do we apply that to prove a given number is irrational. These questions can come for long answer questions, so don't neglect them. In case if you want to look at the few more questions, you can check at the notes section, and you can look at this summary also in the notes section. So if you are confident enough, you can write the test. In case if you haven't taken the EduRev Infinity subscription, do it today. Thanks for staying tuned. All the best.